So Pui Wing introduced my guest as Mike Schrepfer. Here in Silicon Valley, though, he is not known as Mike. He is universally known among technologists as Shrep. So my question, first big question, what about reporters like me? Am I allowed to call you Shrep?
I may have to consult my bot to answer that question.
Fair enough, fair enough. The reason I'm interested to talk to Mike, and I'm always interested to talk to Mike about this particular area, is that he was there when all this hype got started. So basically, around 5 years ago, there were these methods called neural networks, which are essentially systems that can learn tasks like recognizing a face in an image by analyzing vast amounts of data. So to take Facebook as an example, you know, you've all used it. It can recognize your mother's face in an image. The way that is trained is it's trained on millions of photos. This method started to work for a lot of different reasons. Basically, we had the data, we had all those faces, and we had the computing power suddenly, and it started to work. And what happened about 5 years ago at places like Facebook is they realized there were a limited number of people who specialized in this, and they started buying them. Explain the dynamics there. Like, at what point did you realize what was going on, and how did you go about finding these people, and how quickly did you bring them in?
Yeah, it was, you're right, the timing was around 2013, and Fei here was talking about ImageNet, which is this database of labeled images that people use to test out their algorithms. And I think it was in 2013, you know, for years at the computer vision conferences, they weren't very big and very well attended, and there's these benchmarks, and you'd see this, you know, the best paper would get a 0.1% improvement on this, you know, benchmark, well below human capability. So it was kind of going at a snail's pace. And then all of a sudden, I think it was 2013, someone showed up and applied neural nets, was a technology really from the 80s and 90s, but enhanced with data and compute, and blew away the competition. You know, it was like many percentage points better. And we had already at that time, we were deploying what I'd call classical computer vision algorithms at Facebook. We're using face recognition, we're doing some object detection, other things like that, using traditional techniques. And obviously we saw this and we said, wow, this is, you know, a state change you're not used to seeing in technology, and realized that we wanted to kind of go big in AI. And this was a big deal. I spent a lot of time talking to Mark about it, because prior to this, we didn't have the concept of a research lab at the company. Right. You know, we're very focused on day-to-day impact and what we were going to get done, you know, right now, move fast and get things done. And you know, rather than build a generic, you know, multi-purpose research lab, we said, well, we want to go all in on AI, because it's clear that we could never invest too much in that. And luckily, it was a small enough time that I just picked up the phone and called everyone. I called Yoshio, I called Jan, and you know, I said, you know, who's doing interesting work and what should we do? And Jan and I, Jan LeCun, who is one of the pioneers in neural nets and based in New York, kind of hit it off. And we decided to, at NIPS that year in 2013, which is the big conference, machine learning conference, announced that we were building a research lab with Jan at the helm.
Well, the other dynamic that's going on there is that Google had already built a lab. Others were starting to do so. And literally, they're paying millions, sometimes double-digit millions, for these researchers. They were that much in demand. And you know, I don't expect you to go into your list of salaries, but—
I have a spreadsheet right here.
Right, exactly. But trust me, the salaries are that high. At this point, you know, that may or may not be changing depending on who you talk to. You know, the number of people available may or may not. But you're paying a lot of money for these folks. We're 5 years in. You know, Jan LeCun will tell me that the lab is now paying for itself. Is that true?
Oh yeah.
What is the lab doing for you specifically today?
Well, we can talk about, you know, so first of all, take a step back and say, why do you need research in AI? Because, you know, I think a lot of people stare at it and they think that AI is a solved problem. You see AI doing these amazing things, but there's so many key pieces of information that show that we don't understand a lot of core things about how AI works. There's one very specific example, you know, game playing is an interesting way to test out AI, and so there's been a lot of great work teaching AI to play 1980s Atari games. And they can do phenomenal things. They can play really well. But you compare it to a human, there's a paper recently that talked about Frostbite, which is an Atari game that's particularly hard for the AIs, and a human who's never played the game before, in about 2 hours, can get a pretty good score, 4,000 or 5,000 points. To get an equivalent score in AI will take maybe 500 to 1,000 hours of training, right? So it takes 100 times, several hundred times more work to get to the same result. And that's because the AI is kind of like, it's kind of like a newborn being born and given an Atari joystick and saying play Atari without any knowledge of the world. It doesn't understand physics, it hasn't played other games before, kind of starts from scratch and gets really good at this one thing. As a human, you bring all this knowledge to the equation. So that's one example of many different parts of AI, and I could give you 6 others that like we just don't have the basic tools to solve the problem. So, so you want to build a research lab.
So given that, like that's fascinating for, you know, in the abstract and for people like me who write about this stuff. But what about like practical stuff today? Like we talked about, you know, face recognition. That's one thing, right? That's not worth the tens of millions of dollars in salaries alone, right? So practically, what are these techniques giving you today?
Yeah, and let me give you a couple examples. You know, you talk about the war or the quest for talent, and I think, you know, obviously compensation is part of it, but I find a lot of people, you know, in this field, what it is, am I going to be able to do my best work, and is it going to be able to show an impact in the real world? And that's where I think we do really well, because you have this research lab sitting right next to the product teams deploying things. So, give you specific examples. Billions of translations happen every day on Facebook. People want to talk to friends and family in their native language. You know, our research team came up with a new technique, neural machine translation, much better results with much less
Same techniques as for image, right? I mean, roughly speaking,
it's,
right?
It's inspired by a lot of those things, but it's specific to translation. You know, by the time the paper was at the academic conference, we had the code rolled in production. You know, last year, our computer vision team, you know, kind of won a prestigious award at the top computer vision conference for a concept called Mask RCNN. It's a state-of-the-art technique for labeling and identifying where an object's images are. You know, that code is also rolled into production. It's in your iPhone app. It's helping billions of people every day. From, among other things, you know, it will auto-label and caption images. So if you have a vision impairment, you can have a caption read to you. It also just helps to make sure you see the best stuff. So we can tell the difference between a, you know, picture of someone's latte art and you know, picture of your niece or nephew. You'd probably want that in your news feed, not the coffee.
Fair enough.
You know, or maybe vice versa.
Right.
What you're interested in.
So how about this? You know, one of the chief problems if you're running Facebook is you've got to deal with a lot of content that you don't necessarily want users to see, right? You have, you know, you have certain, you know, conditions that you place on a user. You know, you don't want to see pornography. You don't want to see beheadings, right? And in theory, you can take these methods and you can identify these types of things in images automatically. Now, I know to a certain extent you can do that, but like, to what extent can you really do that? If we just limit it to, say, pornography, to what extent can you build an automated system to recognize that and lift it? And to what extent do you still have to rely on people who are, you know, overseas, you know, actually having to review that and actually having to click a button to make a judgment call?
Yeah, it's a great question, and look, let's step back, because obviously I think this is the most important thing we're working on right now, which is just keeping the community safe, making sure the content that shouldn't be on Facebook isn't there. The core idea of Facebook is connecting with family and friends and being close to them, and when you see hateful comments or pornography on Facebook, it just it's just terrible. And so this is where and I actually focus a lot of my time and energy here. To be very specific about this, you know, nudity and pornography is one of the first places we're able to deploy computer vision to automatically flag the content, so it could be reviewed, you know, by someone in the company and see.
But that's key, isn't it? It still has to be reviewed by, you know, essentially a lot of people that you're hired. You've well,
tens of thousands.
Tens of thousands of people who you pay money to make that final.
Yeah, in some cases the classifiers can get good enough that we can take some action immediately. So a human may review it, but we may, for example, quarantine it so it's not published. Because the problem without AI is anytime someone publishes something on Facebook, you know, billions of pieces of content a day, you know, we would wait till someone else saw it and they say, wait a second, that's not supposed to be, you know, report it to us. Then we review it, then we take it down. By the time all of that's happened, it's likely other people saw it too. And so the kind of damage is done. The really exciting thing about the prospect of AI here is like we can say, okay, we're pretty sure this is not okay. We're gonna like, you know, downrank it or put it in quarantine. Then a human's gonna review it because we want to, you know, make sure we're not making a mistake here. Because on the other end of this is terrible if we have a mistake, and then we can kind of figure out what to do. But you know, I'd say the vast majority of nudity and pornography reporting now at this point is automatic. It's from AI systems. It well outpaces what people report.
That's interesting.
And we've started to see recent progress in things that I thought we were not going to be able to do which is like uncivil discourse and hate speech and hurtful comments and things like that, where we're seeing early results that are promising to do that. And then again, it speeds up this loop, so instead of a bunch of people seeing this terrible thing, we can kind of get it out of there and back into the system.
Well, speaking of judgment calls, and as a segue to maybe some more difficult questions in this area, explain the situation with that famous photo from the Vietnam War, which I think shows that as good as the systems get, that ultimately there are things that are really human judgments that are almost impossible to duplicate.
And this is a really good example of what I'd say where AI systems can go wrong. And this wasn't an AI problem, but it's a good example of one that could, which is often there's a lot of external context that's not part of the photo. So if people aren't aware, this is an iconic historic photograph of the Vietnam War. It's a naked child running away from a napalm attack. And so if you don't have all of that context and you just look at this, it's a naked child.
Right.
And that is by far the worst kind of content we want off the platform immediately. And so based on just that, you would take that content down. So that's clearly not allowed on Facebook. And then you have to revise the policy and say, well, that photo has historic significance. It's been in museums. It is part of the historical record. And because of that conversation, it was restored and put back up. But these are the conversations we need to increasingly have with people about what do people want on Facebook, what's okay and what's not. And that maybe varies from community to community.
But how does that
and that's an ongoing dialogue.
It is. So how does that relate to AI? Does that mean because ultimately those are judgment calls that problem is unsolvable with automation?
I'd say whenever you are debating what your policy is, you are unlikely to build an AI that's going to work well for that, right?
Right.
Or whether you're, let me give you another example, which is bullying in schools. I may say, nice jacket.
Right.
Maybe a compliment.
Sure.
Or maybe all day at school, you got made fun of about your jacket.
Got it.
And that comment is the most hurtful thing someone can say.
Got it.
The AI system doesn't know what happened at school today and won't anytime in the near future.
Exactly.
And so that's one of those ones that I'm not really sure how you automate your way around.
So that's a good segue into my other questions. When you talk about like debate over things, we've got this national debate over Facebook and the role it plays and how it deals with bad actors and with types of content. I mean, if you take the fake news example, there's been a lot of talk about this, and some people will claim, well, you can just solve the fake news issue with AI, but you farm that out to humans again, separate organizations from Facebook where we have people making judgment calls there. Is that an area where any of this stuff helps now, or do you think it can help in the future?
Yeah, I honestly think if we didn't have the advances in AI, we'd be this would be hard to solve at the scale we're operating at. Billions of pieces of content a day. False news is a really good example of this. In terms of the difficulty of these sorts of problems, because I think there's two sorts of problems we face, two classes of problems. One is just people don't understand or they make a mistake. Right? They post something, they didn't know it was against the rules, and you explain to them like, oops, sorry, won't do that again.
Right.
The other, which is much more insidious, is basically adversarial actors, right? You traditionally call this a spam, or maybe this is a government actor, and they are trying to get this content out there. They're trying to get this piece of false news out there because it advances their message. And as a result, they're very smart. And so it's an arms race, it's a cat and mouse, where we build a classifier that figures out that this looks like that, and we've figured out that this text is false. They will alter the text slightly to make sure it doesn't go through. Or they figure out in placing an ad that's against our policies that we're reading and classifying the text in the ad. And so instead what they do is they put text in the image in a way that's hard for OCR to do to try to sneak it through. And so it's a process where people are actively trying to subvert it.
Right.
And I'm not saying that makes it okay that this stuff, I mean, we take this really seriously, but it makes my job really hard because we've got to build these systems at constantly evolving threat for all of these things. And that I think is part of the challenge.
Right. That's an old story in Silicon Valley, certainly on internet services like yours, is that cat and mouse game. So whether you call it AI or you call it whatever else you want to call it, does that mean that just continues? You get some people say we can just build AI. Your own head of your AI lab at one point said we can build AI to stop fake news. I think that's a stretch. Like, does that just continue into the foreseeable future?
I don't know. We'll see. I think there's some promising capabilities, but the adversaries are sometimes using similar techniques. They're using AI to auto-generate fake images and fake news stories and other things like that, which means they can generate a lot more, than just human-generated. So I am optimistic. I mean, I'm a technology optimist, and I think I think we're seeing in most of these things with a huge focus on it. And actually, it's the collaboration of AI plus humans.
Right.
So, sometimes the AI is not so great, and then classifiers aren't so great, so you don't want it to do anything automatic. But it can, instead of looking at everything, we can limit it down and say, well, there's this stuff, and this sort of looks sketchy.
Okay.
Like, let's have a team of people go look at that.
Okay.
And that combination, I'm optimistic with ongoing investment. We can certainly do a lot better than we're doing today.
Okay, got it. And a slightly separate issue, what about just identifying the bad actors? Meaning not necessarily content, but just identifying the person or the entity that is behind the content. Maybe the content itself looks great. Can these methods really help there?
Yeah, they can, and this is the idea that someone will create a fake profile. They create a Facebook profile, and it's amazing how sophisticated. I mean, sometimes they'll spend 6 months building this fake profile, and there'd be a sleeper profile, which they don't do anything wrong or against our policies. They friend a lot of people. They post what looks like normal content, and then boom, they turn it into something that is a vector for spam or malware or other things like that. And so, yeah, AI can be very helpful because you're fundamentally trying to say is this account behaving in some way that is against our policies or wrong or different, and can we detect it and figure it out? And then what are the signals we would get that would do it? So it can be very effective for that as well.
Got it. All right, I'm going to open up the audience. Can they call you Shrep? Is that okay?
Call me anything you like.
All right. Anybody?
Hello. I have a question regarding pornography. I come from Switzerland, and in Switzerland, we allow what we call soft pornography, and we forbid hard pornography. And it is ruled, by the criminal code. And for instance, a hard pornography is with children, animals, or very violent acts. And considering that, so the legal framework and ethics too, we will forbid, hard pornography. You said about, if it is nudity, then it's forbidden and all that. So do you also act, upon certain criteria, like the law? I mean, like ethics, or how do you proceed? Because it's really, I mean, it's not clear cut,
It's a great question, because I think social norms and laws vary from place to place.
Yes.
And so I think
Yes.
we always start with, we have to abide by the laws in each of the regions. And so that's what I'd call as a minimum bar, is that we need to be lawful in all of these things. Then we have the community policies at Facebook, which are often more stringent than the law. So, a lot of what you say is acceptable in Switzerland is not acceptable on the community standards on Facebook. I think, over time, we hope to make sure that those community standards reflect each of the local communities well. So if there are differences in those communities, that we can better reflect that on Facebook. But right now, it's sort of a general standard, and it's meant, it's meant for family and friend interaction, for kind of civil discourse. We don't have an opinion on that stuff, but that's just not what we think Facebook is for. There are other services or ways to distribute that sort of content.
All right, how about one more?
Hi.
Hi.
So you have 2 billion people. You could make the argument that you guys have outsized influence on the trajectory of AI. What kind of ethical frameworks are you putting in place to govern your behavior, not just because you should be behaving yourselves, of course, but also because you set, as I said, sort of an outsized example for how the world is going to be affected by these things?
This is a great question. It's actually an active area of research we're contributing in. As an example, the very recent 2017 NIPS conference, which is the largest machine learning conference, Mustafa Sise from our Facebook AI Research Paris lab presented some really great work on bias in algorithms and axiomatic algorithms. And I think this is a place where trying to figure out how to determine what the principles you want of the system to be, and then ensure that that system does it, whether it's AI or humans. So take this out of Facebook for a second and talk about any time you're making a decision, should you pay for or not pay for a medical procedure as an insurance provider? You may have a human making that decision, or you may have an AI making that decision. Well, you need to decide up front, what are the factors that I can consider in there? Am I allowed to consider economic status or race or gender or any of these things, or is it just medical history or total expenditures or whatever it may be? And kind of for each of these problems decide these are the things that we are allowed to make this decision on and these are the ones we're not, and then ways to ensure that that happens in it. The one thing that's interesting is I'm actually optimistic that AI systems are going to be a more reliable way to encode that than humans. So once we decide what they are, it's fairly easy to validate whether this AI system is abiding by those principles or not. You know, a group of humans, there may be variances in what they do. And so, you know, there is opportunity here, and it's an active area of research for us.
Mike, thanks for coming.
Thank you. It was fun.
Should I say
Appreciate it.
Right.